Welcome to another video. In this video, we will do a t-test for two means paired sample, or what we call dependent samples, using Data Analysis Tool Pack in Excel 2016 Office 365. For this video, we also prepared the problem that we're going to look at. So here we have a shoe manufacturer claims that the athletes can increase their vertical jump heights using the manufacturer's new strength shoes. We selected 8 players and we recorded the jump heights with and without using the shoes. So without using the shoes is the old one, and after they put the shoes on, that's the new one. Assuming the vertical jump heights are normally distributed, is there enough evidence to support the manufacturer's claim? Now, the manufacturer claiming what? That using the shoes, they will increase, so the new height will be higher than the old height. It's very important when we're doing a paired sample test to know which one we're going to take as the before, which one is the after. Since this is the old and this is the new, if we take this the before and this is the after, then the difference between them will be negative. If we take it the other way around, then the difference will be positive, and that will affect our hypothesis and the claim. So for this example, we're going to take this is the before and this is the after, which means D is jump height before shoes minus after. Then mu D, in this case, the claim increase means mu D will be negative, less than 0. And we place it in the alternative, which means the null hypothesis will be greater than or equal 0. So mu D less than 0, negative because the old is less than the new, because he's claiming that it increases the vertical jump height. So for this test, we're going to go to the data analysis as we did with other tests, but this time we're going to choose the t-test paired to sample for means. We're going to select the variable one range. This is very important to select the same one you selected as the before. So we're going to select this first. We're going to select the second one. And the mean difference, as we see in the claim, it's 0. Alpha is 0.10, they want it at the 10% level of significance. And the output, let's place it over here. So now we have all the result. Now, looking at the alternative hypothesis, it's less than, so we know that we have a left tail test. This is the t-stat. This is the critical value. And this is the p-value if we're comparing the p-value. So if you look at the p-value, it's less than alpha, which means reject the null. If we look at the t-stat, it's to the left of minus 1.414, which is the critical value, which means also reject the null hypothesis. So based on these values that we get from the test, we can see that the decision would be to reject. Rejecting the null means we have enough evidence to support the alternative, and the alternative means negative. Mu D is negative, which means it's the claim, because negative was increasing the vertical jump, and that's why we got mu D negative. So based on that, we can say that at the 10% level of significance, there is enough evidence to support the shoe manufacturer claims that the athletes can increase their vertical jump heights using the manufacturer's new strength shoes. So in this test, it's similar to the other test that we did, except that you have to be careful in the beginning to decide what's your D, which one you're going to take the before, which one the after. And based on that, the claim will be either negative or positive based on the context of the claim. So it's very important to specify D first before you look at the mean and before you decide on the claim and what goes in the alternative, what goes in the null. Thank you for watching. Don't forget to subscribe for more videos on my channel.